Hi guys, welcome back to another lesson. In today's lesson, we're going to do our final little step in our probability, and we're going to be looking at calculating the experimental probability of an event. So let's get straight into it. So what is experimental probability? Well, experimental probability is the probability or the chance of a particular outcome occurring based on the results we're already seeing. So it's working out the probability of flipping a heads after we've flipped a coin 300 times and getting 100 heads already. Okay, so it's using information we already know from some of the experiments we've already done. How do we calculate the experimental probability? Well, we calculate it the exact same way we calculate theoretical probability. We just use slightly different values. So let's do some let's talk first about calculating the expected number. So expected number is us working out, well, if we get this probability so far and we multiply it by how many numbers there are or how many times we do the experiment, that will give us our expected number. So probability we know to be, the number of successful trials over how many trials we completed, and n is the number of trials, so how many times we complete the experiment. Now let's do an example. So calculate the experimental probability of obtaining a spade if a card is drawn from a deck and replaced 300 times and 81 spades are obtained. So we know how many spades we're getting and we know how many times we're doing the experiment. So what we do is we say the probability equals number of successful trials, so how many times we get a spade, over the number of times we completed the experiment. So probability here equals 81 over 300, which gives us 27 over 100. Okay, let's find the expected number of tails if a coin is flipped 250 times. So expected number means we use the probability times n. So the probability would be, well, there's one chance of us getting a tail every time we flip a coin out of two possible outcomes. So we do the probability of tails is 1/2. And so the expected number of tails would be 1/2 times 250, which would give us 125. So what we're saying here is we expect to obtain 125 tails if you flipped a coin 250 times. Now, let's do a multiple step example. So a die is rolled 300 times. What is the expected number of sixes? Okay, that's the first question. We'll go question by question. So what is the expected number of sixes? So expected number of sixes equals 1/6, because that's the probability of us getting a 6, because there's 1 6 on a dice out of 6 numbers. So 1/6 times 300, which gives us an expected number of 50. So we would expect to get 50 sixes if we rolled the dice 300 times. Okay, if 45 sixes are obtained, find the experimental probability of rolling a 6 and compare it to the theoretical. So the theoretical would be like 1/6, but the experimental probability would be 45 over 300, because we've got 45 sixes obtained out of 300 rolls. So that gives us a probability of 3/20, or as a decimal, 0.15. If we compare that to the theoretical probability, that's where we compare, we say there's 1/6 on a dice and there's 6 numbers, so we get a probability of 1/6. This is before we were to complete any sort of experiment. We get 1/6, and that broken down would be 0.167. So we can see that the theoretical probability is a little bit higher, which means we're not getting as many sixes as we would have thought before we did the experiment. So here the experimental probability of rolling a 6 is 0.5, which is slightly less than the theoretical probability of 1/6, or 0.167. So let's state what we would expect to happen to the experimental probability in the long term. So the more we do the experiment, the closer to the theoretical probability we would get. So because our experimental probability is slightly less than our theoretical probability, as we completed this experiment more times, we would find that the experimental probability should increase to become close to the theoretical probability. Because over a really long period of time or over a lot of experiments, we would expect those two to become closer and closer. Thanks for watching, guys. Remember, if you have any questions, please make sure you ask. Otherwise, I will see you in the next lesson. Bye.